A bearing has dynamic capacity of 50 kilonewton. What equivalent load it can carry for the average life of 6000 hours at 500 rpm? So here a bearing has dynamic capacity of 50 kilonewton. So a given dynamic load capacity. So first of all let us write given data. So a given dynamic load capacity. So dynamic load capacity, so generally denoted by C, capital C. So C is equal to given 50 kilonewton, and at the same time we have to find equivalent load, equivalent dynamic load, equivalent dynamic load. So we have to find equivalent dynamic load. So equivalent dynamic load is denoted by W, capital W, is equal to what? So we have to find equivalent dynamic load and given average life in hours. So service life in hours. So service life in hours is given. So LH denoted by LH. L suffix H, life in hours. LH means life in hours. Okay, na? So service life of bearing generally measured in hours or revolutions. So life in hours, how many hours? 6000 hours. 6000 hours. Next, given speed. Speed of bearing. Speed denoted by capital N is equal to 500 rpm. 500 rpm. Revolutions per minute. So we need equivalent dynamic load. To solve this type of questions, I am going to use two formulas. So the first formula is service life or rating life. Service life or rating life of ball or roller bearing. Ball or roller bearing. Service life or rating life of ball or roller bearing is given by L is equal to capital C by capital W whole power N into 10 power 6 revolutions. REV means revolutions. So this is formula for service life or rating life of ball or roller bearing. L is equal to C by W whole power N into 10 to the power of 6 revolutions. We have one more formula. So relationship between service life in revolutions and service life in hours of a roller or ball bearing is equal, L is equal to, so L for service life in revolutions is equal to 60 into N into LH revolutions. Okay. So this is the relationship between L and LH. L means service life of bearing in revolutions and LH means service life of ball or roller bearing in hours. Okay. Using these two formulas we can find equivalent dynamic load. So service life of bearing in revolutions is equal to C by W whole power N into 10 power 6 revolutions. Okay. So here L is service life of roller or ball bearing. So here N is constant. So N is equal to 3 in case of ball bearing. For ball bearing, so here N value is equal to 3, and in case of roller bearing N is equal to 10 by 3. In case of roller bearing, value of N is 10 by 3. And what is C? So C is dynamic load capacity, W is equivalent dynamic load. So anyhow we need W. Okay, now we have to find equivalent dynamic load. So to find W, first of all, C value is already given. C is equal to, given that bearing subjected to how much load? 50 kilonewton. So we given basic dynamic load or dynamic load capacity. C is already given. So we need W. Okay, now at the same time L. So how do we get L? Bearing life in revolutions. There is a relationship between bearing life in revolutions and bearing life in hours. L is equal to 60 N LH. So here N is equal to how much? N is already given, 500 RPM. At the same time, LH is equal to life of bearing in hours, 6000 hours. 6000 hours. So using N and LH we can find L. L is equals to 60 into N how much? 500 into 6000. So 1, 2, 3, 4, 5, 6 zeros. So L is equal to in 10 power 6 units revolutions. So 6 5s are 30, 36 are 180. So what is the value of L? L is equal to 180 into 10 power 6 revolutions. So next, so we need W now. Let us use this formula. L is equals to, so L value how much? 180 into 10 power 6 is equal to C by W. C how much? 50 kilonewton. So 50 by W whole power n into 10 power 6 into 10 power 6. 10 power 6, 10 power 6 get cancelled. You will get 180 is equal to 50 by W whole power n. Apply nth root on both sides. Apply nth root on both sides. Nth root on both sides. So if you apply nth root, we can eliminate this power n. That's why I'm applying this nth root. So nth root, we are applying nth root. So nth root of 180 is equal to nth root of 50 by W whole power n. So this nth root and n get cancelled. You will get 50 by W is equal to nth root of 180. Okay. We need W. Take reciprocal. So W by 50 is equal to 1 by nth root of 180. Okay. Next, transpose 50. We need only W. Division becomes multiplication. Now W is equal to, so division becomes multiplication. You will get 50 by nth root of 180. Okay. So here W is called equivalent dynamic load. So here we need to find equivalent dynamic load. So first of all, we should know value of n. So in the question, we do not have any information about type of bearing, whether it is ball bearing or roller bearing. So let us assume two cases. Case 1, suppose the given bearing is ball bearing. If you consider ball bearing, then so manaki question lo mention cheyaledu adi type of bearing. For example, ball bearing aithe n emotundi, n is equal to 3. Then W is equal to equivalent load is equal to 50 by cube root of 180. So if you simplify this, you will get approximately 8.86 kilonewtons. So if you consider ball bearing, then equivalent load will be 8.86 kilonewtons. Next, let us consider case 2. So case 2 is roller bearing. Suppose my bearing is, for example, roller bearing. Then what is the value of n? So value of n is 10 by 3. Then equivalent load W is equal to 50 by 10 by 3 the root of 180. So if you calculate, you will get around 10.53 kilonewton. 10.53 kilonewton. Okay, na? So ball bearing, if it is ball bearing means then equivalent dynamic load is 8.86 kilonewtons. Suppose if we consider roller bearing, then equivalent dynamic load is 10.53 kilonewton.